we are talking about exercise 3B, that is increasing and decreasing. So I'm just going to draw a bit of a curve here. Now it's increasing if, now we're always talking about x going from left to right, so you've just got to imagine you're walking along the x-axis from left to right, like you would read a book. And if you're walking upwards, then you're increasing, and if you're walking downwards, then you're decreasing. Okay? So that's increasing, decreasing. Now we can use calculus methods to determine it. We can just graph the function and see where it's going up and where it's going down and where the maximum points are and the minimum, and see, oh, it's increasing up to there and then decreasing there and then increasing. All right, but we're talking about how do we use calculus methods to make these statements and become aware of these things. So remember, if we have f of x, then f dash of x is the slope. And the slope tells you how steep a line is. And so when it's increasing, we're going to have positive slope, all right, because we're going up. And when it's decreasing, we're going to have negative slope. And so that means our calculus method that we're using here is we're just going to find f dash of x and draw its sign diagram, because a sign diagram tells us when a function is above the x-axis and when it's below. That is when we have positive slope and when we have negative slope. So let's get into our first example here. We've got y equals x squared, take 4x plus 2. So our process is to find the derivative and draw the sign diagram of the derivative. dy on dx is going to be 2x take 4. This is the equation of the line, so it's going to have a sign diagram that looks like this. The root is going to be positive 2. And I know it's going from the negative side to the positive side because we have a positive slope in this line. It's a straight line. Now, if you're not sure what I've done there, you can graph this, all right, in your calculator and just get the sign diagram. All right, but I've just made a bit of a jump there. The root is 2, so that's what I put on there. And then I'm saying, when is this line negative or positive? Well, it's got positive slope, so the line's going straight up like this, which means it's going from the negative to the positive. If we have negative slope, then it's going to be going from the positive to the negative. Excellent. And so then, this function here, this quadratic x squared take 4x plus 2, has negative slope when x is less than 2, and it has positive slope when x is greater than 2. So what that means is it's increasing when x is greater than or equal to 2, and decreasing when x is less than or equal to 2. Now, why do we include the value that we're talking about? Because you might say, well, at point 2, it's not increasing, it's not decreasing, it's horizontal. And the answer is, this is just a technicality, okay? So it is wrong to say it's increasing for x is greater than 2. We must include the point from which it starts increasing. All right. So if I'm going to draw this function, x squared take 4x plus 2, it's going to look like this. It's a quadratic that looks like this. Okay? And you can see we've got negative slope up to this point, which is x is 2, and then we've got positive slope, it's increasing. If we've got the equation of the line, so this is the equation of f dash of x, it's going to look like this. All right? Where this is 2. And we can see it is negative and then positive. This is the slope of this function. Okay, we have negative slope until we get to 2, and then we have positive slope because the slope function has gone from below the x-axis to above the x-axis. Okay, let's not spend too long on that, so it's a simple one. Okay, this one here, we're going to use our calculator a bit. We've got f of x is x squared, take 5x, take 36 on x plus 2. I'm going to give you a moment to find the derivative using the quotient rule while I get the calculator set up on the screen. make sure, let's fully expand it and collect all our like terms. Okay, so I'm going to go into graph mode. I'm going to delete all these functions and I'm going to graph three things. Okay, first I'm going to show you a little trick. Let's put in the main function first. So the main function, I'll just put a fraction there first, is x squared. Take 5x, take 36.
Wouldn't there be a 2x cubed? Is 2x times x?
2x times x is 2x squared.
Oh, shit.
Yeah, no, you're right. 2x take 5x on top of. Okay, so that's our main function, all right? Now we've done this process here to demonstrate the derivative function, but here's how we can rely on our calculator a bit. Because even if we can't get this process, or even if we do it and we get it wrong, we can still get our calculator to generate the right graph for us. Now I think I may have shown you this before in the run map. We go option, calc.
I think you press F3.
Option, calc, thank you. D on dx, all right? D on dx, and it's going to say, well, what do you want to differentiate? And we're just going to press y1, okay? Because look up the top there, it says y1 equals. We want to say, well, what is the derivative of y1? Now I've pressed the wrong one there. I've pressed d on dx squared. So hang on, that's the second derivative. So option, calc, oh, this is throwing me out there. Option, calc, d on dx of
Press the wrong
Wrong one again.
d on dx of y1.
What about that x equals? Oh, just
Yeah, you can place x there, but it will do it automatically for you. And now that's going to graph both functions, but we're not particularly interested in the blue one, so I'm just going to unselect it. And so even if you've got this process wrong, it's going to generate the right graph for you. So let's have a look at it.
That's a bit odd.
It's a bit odd.
Mine says no data.
Do you have it selected? Yeah.
Well, how do you unselect? Oh, press select.
Okay, and what we can see here is it seems to have some sort of horizontal asymptote. But the point is, it's never below the x-axis. That this function, there's obviously the vertical asymptote when the denominator is 0. Okay, when the denominator is 0, we have a vertical asymptote. It's undefined at x is -2. It's undefined there, but it's positive on either side. All right. So we can see our vertical asymptote there. See that how it goes up and then it seems to come straight back down. It's getting really, really close to x is -2, but it never touches that point. And then we can see this horizontal asymptote. You can zoom out, you'll see that it's just going to keep going on horizontally forever. Okay, so this is our sign diagram. And so we're going to say this function, f of x, is increasing for, we're going to say x is greater than -2 and x is less than -2. All right, now I want to show you a way that we can demonstrate that mathematically without having to rely on our calculator. And it's going to take us back to Year 11 maths. So what I'm going to do is I'm going to make an argument as to why f dash of x is always positive. So this is f dash of x in the simplest form. We've got, now sorry, I know I didn't put enough space here on the sheet for this one, but you can write this part down the bottom, because this is a bit of an extra part to it. X
Is this
squared plus
for
4x.
question 2? Or?
That's the same one, Ben. Yep, question
Question
2. X squared plus 4x plus 26 on top of x plus 2 squared. So what I want to show you is why this is always positive. Alright? So the first thing I'm going to say is that denominator there, we can see that, and it doesn't matter what number you put in there, it's always going to be positive. Okay, if you put minus 1,000 in there, you're going to have minus 998 squared, which is a positive number. If you put positive 1,000 in there, you're going to have 1,002 squared, which is a positive number. So it doesn't matter if it's 0 or minus 1,000 or positive 1,000. This denominator is always going to be positive, apart from the circumstance where it's undefined. Okay? How about the top? How do we show that the top is always positive? Well, who remembers the discriminant? Okay, so this is assumed knowledge. Let's recover this. The discriminant is b squared take 4ac. We extract it from the quadratic formula. Alright? Let's write up quadratic formula. Minus b plus or minus the square root of b squared take 4ac. 2a. Okay, that's the formula to find the roots from quadratic. This is that square root part, isn't it? It's the discriminant. And it tells us about the roots, okay? So we have, if delta is positive, there are 2 roots. Delta equals 0, 1 root. And if delta is less than 0, no roots. Okay, so perhaps we're seeing that, we're sort of remembering it. So look at this. This is the quadratic formula. This is the part about discriminant. This is the quadratic formula. It tells us if the discriminant is a positive number. If we have a positive number in here, we have the square root of a positive number, and the square root of a positive number always has 2 solutions. All right. So if we have the square root of 16, it's positive or negative 4. There's always 2 solutions. So that's how we get 2 roots. If we have the discriminant is 0, then you have the square root of 0, and that thing disappears, and you only have 1 root. Minus b on 2a, you recognise that? Maybe. And if the discriminant is less than 0, that means we've got a negative number in here. We're trying to find the square root of a negative number, which we can't do, so there's no solutions. All right, so there's those 3 circumstances in which the discriminant can apply. So what we're going to do is we're going to find the discriminant of this equation. All right, so in here we've got a is 1, b is 4, and c is 26. Discriminant is b squared Okay, so we've got the discriminant here is negative, all right? For this quadratic, the discriminant is negative. What that means is this quadratic does not cross the x-axis. It has no roots. So there's no values that are going to make this equal to 0. The other thing about this quadratic is that a is greater than 0, all right? So a is positive 1, the number at the front is greater than 0. Now remember, in a quadratic, if a is greater than 0, it opens upwards, it's positive. Right, if a is positive, it's got a smiley face, it's happy. If a is negative, then it's opening downwards. Now here we have a is positive. So that means this quadratic at the top here, if this is the x-axis, it is sitting completely above it, okay? Because it opens upwards. If it's going to open upwards, it can't be below it because then it's going to have roots. So it has to be completely above the x-axis, and it doesn't have any roots because the discriminant discriminant is less than 0. The discriminant is negative. Okay, so we've made a mathematical argument here as to why it always has to be positive. Right? The top has to be positive, the denominator has to be positive, therefore the function is always positive. Okay, we might stop there. Remember a bit about discriminant? Excellent. Okay, last one's less involved. E to the x. I'm going to rub out here. So we've got f of x is e to the x. F dash of x is e to the x. Now, the graph of e to the x looks like this. It is asymptotic to the x-axis, which means it's always positive. Okay, so this is going to have a sign diagram like this. And so we're going to say increasing for all x. And the way we say that mathematically, increasing for x, x belongs to the set of all real numbers. Never decreasing. And isn't this funny? Like, this is f of x, this is e to the x. F dash of x is the same function. And so you can see, if you had to walk along it, it's just always increasing. For every value of x, the slope is always increasing. Always has a positive slope. And that's what this side diagram is telling us. So let's get into those questions. Exercise 3b. Let's see how we go. Use your calculator to help you out. Alice? Yeah, of course.
Mr. Rose.